Yeah, so I'm here with Ted, and we're going to look through the inline threads PR that I put together a couple months ago now, um, which is going to go on the next release. At least that's the plan. And basic idea you can see in the PR is that so far we've thought of threads as something that you're doing um, that you put in a file and you run that file and you do it in a very sort of dynamic way like that. And it's not actually necessary that it be that way. And so what this is trying to do is let you be able to define a thread instead of in a separate file, put it directly in your app or even in the dojo, and just say, okay, here's my thread. I'll pass that to Khan because Khan runs threads nowadays, um, and I'll get the response back, which is a much lighter weight way of doing threads. Um,
Yeah, and I've been excited about this. I'm excited to see this because I'd been hoping for something like this for a long time. That because I always thought the interface to threads, the old interface was, I always thought it was clunky, where you had to first you'd subscribe to a response, like you'd subscribe to the result of a thread, and then poke Spider to say run the thread, and then later you'd get a fact on the subscription saying what the result was, and then you'd get a kick on the subscription saying that the subscription was over. And it's really like this is a request response protocol, but embedded in this kind of clunky way. Um, and yeah, it just really struck me as kind of non-ergonomic.
right. Yeah. Yeah. I mean, it has some advantages, and I'm glad that that still works because it's something that you can just invoke in a convenient way from the dojo. It's something you can invoke through Khan from outside, and it's a way that you can share these if you wanted across processes. It's a good replacement for generators, basically. But threads are more get used for several things. One is as an interface, something that you're invoking directly from the dojo. But another is when you're in an app and um, you want to delegate some relatively complex I/O like outside of the app, so you don't have to write it in this inside-out state machine. The advantage of doing that is it's much more ergonomic. The disadvantage is the only response you get is like when it's done, it'll give you a response, or else it'll tell you that it crashed. You don't get anything more granular than that. But for a lot of things, that's all you need. So
Yep.
we use that pattern in ETH to fetch stuff from an Ethereum node to just say, yeah, every 5 minutes, get me new information. If it crashes for whatever reason, just try again in 5 minutes. We use that in a couple other places as well. I forget where else. Um, but
Yeah.
anyways, yeah. So
There are lots of different threads. It's a very commonly used
yeah,
feature.
yeah. There's a few places even in landscape that it gets used, I think. All right, so this I think makes sense. Uh, there's two commits in this PR. We can review them separately because otherwise it looks a little bit complicated. But it's mostly because we're moving stuff around in the second one. Um, Whoa, I
Okay.
didn't realize that had a big giant tooltip. But yeah, okay. So, wait, no, it's this one's the first one. So this changes two files. So this doesn't do any integration with Con or moving types around. This just updates Spider. Okay, basically changes one file. It updates Spider to support these inline threads.
Okay.
So the there's not even really new types needed because it's just a thread. Um, so we'll just go line by line interrupt me if there's anything that's not clear.
Yeah, and if you can hold it still for a little while so that the text resolves.
Sure. Yeah. Yeah. So first thing is in onPoke, we add an item to so we currently we say basically either you can start a thread, you can stop a thread. We handle HTTP requests. You can send input to a running thread, which is a uncommonly used feature, but does exist. And so we add one more thing that you can do in Spider, which is start an inline thread, which is very similar to starting a thread, except it doesn't like it takes different arguments. I actually think that.
What is the difference in the argument here? So Spider start, it takes start args, whereas inline takes inline args. So what are inline args? Or like I want to see the types.
Yeah, so somehow that didn't end up in this commit, but it's in the second commit. This is the changes to the ser file. So inline args, this is just a renaming. It's the same type. This is inline args as compared to start args. So what it used to be is to start a thread, you tell it what's the thread ID of the parent, what thread ID you want it to use. Both of those can be null. It'll generate its own if you do null for the used one, but then there's no way for you to get the response really. Parent can be null if you don't want it to have an explicit parent-child relationship. You tell it what is its formal beak. So where is this file getting run from? What is the name of the file where heps get turned in, or FASs get turned into heps and so on, just like in structures and libraries. And then you can pass arguments to the thread as a vase, because it has to be something generic, because only that thread knows what the actual type of the arguments are. And so for inline arguments, we do the same thing with thread IDs. We still do require a beak, which doesn't get used to read in a file, of course, because we don't have files, but it's used to validate marks for whatever that thread communicates. So if that thread is, whatever it does, like it also shows up in the bowl of that. But yeah, there are some reasons why you need to have a formal beak.
Yeah, you need that for basically if you're running a thread from another desk, or if you're validating something over the wire or something like that, right?
Yeah, validating over the wire is one of the big ones for sure, because you need to be able to validate that data, and that needs to come off of your desk, and so you need to say what counts as your desk. It's generally safe to just use base there, unless you have a specific mark that you want to reference, in which case use your own desk.
Okay, yeah. And the shed here is a function from base to.
No, well, it's this.
Right. So it's the form.
Let me check and make sure.
The form of the monad, right, which is the thread monad. So it's basically like an expression that can be evaluated. And when you evaluate that expression, it produces like either a continuation and or an effect, right? Either like an effect and then a continuation to run with the result of the effect, or something saying it's done, basically, right? Or an error.
Yeah. So it's this part, the part that's highlighted. Right. So it's a computation. Yeah, exactly what you just said. I think it's a computation that just starts, and might at various points produce effects and yield, waiting for input, and then when the input comes back, keeps going. So the difference between this and
it's like a monadic computation whose result will be a vase, right? Like shed is because the form strand is polymorphic, but in the result type, and so we're saying this is all just going to return a vase. And internally, some of the like internal functions, right, that are sort of sequenced within one of these things may actually return something different, but the outer call signature is that it takes in a vase and it returns a vase. But if it's inline, then there are actually it's not a function, because you're just saying like, here's an expression, go run this. Right. So you don't need to be a function that takes in arguments the way you do for like a thread running from the dojo.
Right, because yeah, this computation sort of is a function already. It's a closure in some sense, and so you can just yeah, the arguments can go directly in it, and you don't
Yeah,
have to
by default, it'll
you
close
know
around all the agent state, right? Like, unless you try to carve that out.
yeah, yeah, it'll have wherever you define it, it might have, yeah, it might have your agent state, it might have just like the libraries that you have included at the top, right? If you use a library only in a thread, you still just put that at the top of your agent. Works fine. um, if
Yeah.
you're running this from the dojo, you can just reference any dojo variables, for example, because they're in your subject at the time you're defining it.
Yep.
Right. So that makes that also just kind of reduces your boilerplate, because you're not having to parse out your arguments. So that's what gets passed in for inline arguments.
Yeah. One thing that strikes me here, it's a little bit of a non sequitur, but I was thinking, like, if you have inline args, the need for start args seems a little bit less, right? Like the need to have sort of like named threads, right? Like where you name the file that contains the thread definition, because you could basically build that out of the inline ones, right? Where you
Right.
essentially just import a function, right, that returns a shed, and
Right.
then you could call that function with whatever. It actually doesn't even need to be a vase anymore. It could be potentially, but you could have something that takes in like a statically typed value,
Right.
I think. And so then, yeah, instead of using this sort of instead of using this, file name based dispatch, you would just say, hey, run this actual shed. And then you could separate out like loading that shed from a file if that's how you wanted to do it.
Right. Right. You could make the like loading it from a file could even just be a dojo feature, in the same way that loading a generator from a file is a dojo feature.
Exactly.
Yeah.
It kind of is already just a dojo feature, right? Or I guess it's dojo and spider. Yeah.
Right.
But you could make it just dojo.
Well, and Khan supports it as well. So there's also a question of, yeah, from outside, like from Unix, there's a few different things you might want to do. You might want to refer to a thread that exists by name and just run that and get the result. You might even want to define one inline, just like actually pass in the source of the thread, which we don't support here, but would be straightforward to do. You just in Khan the vein, you would you would just compile that against Zeus or something, right?
Yeah, it's interesting.
Yeah, there's a few
Or
options
maybe
from out there.
fall into the dojo, but although that's sort of an inversion of control.
Yeah, right. Yeah, it's possible to send it to the dojo. There's a bunch of options.
I guess actually, if we do have a feature, then having the thing that runs threads be the thing that knows how to do that makes sense. How does it work right now, by the way, with Khan? Like, does Khan just shell out to Spider? Is that how it works? Like, if you ask
yes,
to run a thread, does Khan turn around and just ask Spider to do it on its behalf?
Yeah, we'll see that when we get to the next commit, because that will, yeah, we can run through at that point.
Cool.
All right, then, right. So now we take in a poke for inline threads. We parse out the arguments, and that that sends you to here, which looks similar to this, except so prep thread or basically handle start thread used to do this long thing. Now I refactored that to be prep thread, and it takes an each of either a direct shred. What's the? Yeah. I believe shred and shed. I'm not actually sure how it ended. Oh, between these two commits, I renamed them. Shred is shed. So it's just an artifact of the way that we're diffing them. Um, anyways, so it takes that shed directly, um, or it can take the file in the vase. Most everything's the same in this function. The only difference is, well, the way that we generate the thread ID looks a little different because we were putting the file name in there, which obviously we don't have anymore.
Yes,
So,
we synthetic file name, line hep, whatever. Yeah, that makes sense.
right, we put the desk name in there because that's the best we can do, and say that it's
And
inline.
the desk is the desk that the agent was compiled from. If it's inline from an agent, is that how Gall does this?
No, you specify it explicitly.
Oh, really? It's not tied to the agent that actually produces it. I'm a little
Right.
surprised by that, actually. Why not lock those together? Like, why not have Gall just auto generate and say, like, hey, I'm running this agent from the garden desk, and so when this agent spawns a thread in line, that's going to be also from use all the garden desk's marks.
Right. I mean, the immediate reason is that implies that that Gall would be looking through these messages to Khan in a way that right now Gall doesn't look through anything that gets sent out, which is fixable. Or well, I guess it looks through like facts and stuff, but yeah,
Gall does all kinds of process and moves that come out, right? App from internal is pretty complex.
yeah, but only on agent ones. It doesn't do anything on Arvo ones right now, which there's no hard and fast reason it needs to be that way, but that's basically the reason why it is that way. It's also not. Okay. I don't know. It seems not not illegal to run a thread off of another desk. Certainly, Dojo will need to do that. I don't know. I could see it going either way.
True.
Yeah.
Dojo does. Yeah. Yeah, I guess it just seems weird to me, right? Like, I'm an agent, I want to run an inline thread, but that somehow is like on another desk.
It'll use the marks of another desk.
Like, Dojo absolutely needs to be able to do that.
Right. And you could have two different moves. One if it's that's the normal one, and then one that requires elevated permissions that lets you run it off of any desk and so on. Yeah.
Yeah.
But yeah, that's how it's working here. And so obviously, yeah, handle start thread, handle inline thread are just invoking this with the different arguments. And so, right, so the thread ID gets generated a little bit differently. And then here we say, so once we get to here, we say basically if it's an inline thread, then we go ahead and run it immediately. Otherwise, we go and send a warp to Clay, and that's going to come back on handle build, which is right here.
It's not the same code that was there. Only do it in the non-inline case, right? So we basically just added an inline case here.
Right. We just took this and shifted it over, and yeah. So in the inline case, we go straight to begin thread. This instead. Yeah. So in the non-inline case, we do just like before. We send this warp. When we get the response back, we try to parse it, make sure that it's actually a thread, and then we go ahead and call the argument, right? Because in the non-inline case, we have arguments that we're going to be passing into it. And then one thing I will say that terminates in begin thread, which is the same as what we had up here. Say again.
One thing I'll say is that we should rename either start thread or begin thread, I think, because those are synonyms.
Yeah. Let me see if I can understand what precisely start thread is doing before it yields to begin thread. So it gets from so we have a starting state up at the top here.
It looks like it's basically it's assuming that it's like a function that when you call it produces a shed instead of just a shed. And so it's calling it and then delegating to begin thread.
So starting holds the vase of arguments. And so by the time we get to start thread, we are we get those arguments, and then we call that thread with those arguments. If that fails, we do that. Otherwise, if it does not fail, then we delete it from starting because it's no longer starting anymore, and we call begin thread. So yeah, it's saying basically apply arguments. What's a good name for that?
Apply maybe. Fire, kick, slam. We're slamming a gate.
Slam thread. Yeah. That's not bad. Let me just do it right here. This will be pretty quick. What do we call it? Start thread. I won't like make it compile or anything, but just change it enough that it'll break compiling. Right, slam thread. Yeah. Cool. Yeah, that's a good idea. Because otherwise you have to actually read the code to understand what's happening. That'll at least give you a hint.
Yep.
Right, and then it's begin thread is almost. I mean, arguably it's begin shed. Maybe that's better.
Yeah, I was thinking like
because technically it's not a thread anymore. Yeah. Thread is a function from vase to shed.
Okay. Yeah, it'd be good to keep that consistent then.
Yeah.
But some of these other ones are like stop thread. That's probably also like stop shed, really.
Yeah, that one's a little more like you need some term that counts for both.
Yeah.
And thread is what we've used historically. I mean, but also thread is not a great name. It's possible we could just.
I would actually greatly prefer if at some point we changed it from thread to basically anything else, because thread means
it's so misleading.
Something very specific. Yes, and we're usually pretty good about not redefining words.
Right. I wouldn't have a problem, saying everything, switching everything either slowly or at once over to shed, just being like it's fine. Shed it doesn't invoke much of anything, but at least it doesn't invoke much of anything. Yep.
Strand is also fine, I think.
Strand is fine. Yeah. That's an option. Currently, strand is used. Like the distinction right now is strand is the whole like data structure. Strand of vase is a shed, and then a function from vase to strand of vase is a thread. And in practice, those get used in very specific ways. But
I didn't know that, actually. I didn't know the distinction.
Yeah.
We could also change the direct from Ted to sad.
Right. Yes. Lots of options. Okay. And so that's.
Although I often thought it should be under something called like run or something like that, right? Or script.
Run's not bad. Like that. Yeah.
Actually, calling it a script also might be okay. I feel like this really, when I describe threads to people, I call them monadic scripts.
Yeah. Yeah. Script is a good name for some of that stuff. Especially what is currently a thread, from vase to vase, because script implies a certain like dynamicity that the vases are giving you.
Yeah.
Yeah. Script is not bad. All right. So that's implementing the feature in Spider. And then the next diff is a little bit more just like moving stuff around. So this is the whole thing. Let me look at just the second diff. Right. So I renamed shred to shed because when it's in user space, you're like 5 letters, 6 letters. What does it matter? But once you move it into lol, you're like everything else is 4 letters.
Yep.
And so there's just that renaming going to lol. I've started generally using basically XX to mean don't release until this is fixed, and to do as well, do this at some
That's
point.
interesting.
Someone
I'm
asked
down to
me,
standard.
do we have a standard? And I was like, this is kind of how I use it. And so,
Yeah, I think we should standardize on that.
yeah.
Or the other way, if it's keeps it more likely, because I think we have more XXs than to dos in the code, but those have already been released.
Yeah, but like
Anyway,
to me, XX, like the point of XX is to grab your eye, and to do is somewhat less that way. It's a very
okay.
What is it, Kiki and Boba or whatever, and like that grabs your eye.
Oh, it is. Yeah.
I don't know. It doesn't matter significantly to me, but I've been for probably 6 months now habitually doing it this way ever since someone asked me if we had a standard. Anyways, right. So we define shed in here. Oh yeah. Instead of strand, although everything for the purposes of here, at least it's 4 letters. Maybe one day that'll be a vein name as well. We'll see.
Named after the Rand Corporation, presumably.
Yes, definitely. Right. So this all comes from libstrand. So now we're putting it in lol, where it has its own interpretation of card, its own interpretation of input, strand input, its own version of lol. Say again.
Is this exactly the same as what's in libstrand?
It is almost exactly the same, and in particular, this is the new libstrand, so everything's fully compatible because it's just Rand.
Got it. Okay.
Yeah. Notably, right. So I had some. So this is actually defined parallel to con, like along with all the other veins, which is not ideal. But the problem if you don't do that is this basically. This refers to Gaul, which is defined in the same core, and so this is that case where you throw the compiler into an infinite loop if you have 2 relatively deep references to each other inside the same vase, because you have to compile the one to know the type of the other, and vice versa.
You mean inside the same core?
Inside the same core, yes. Where you have so you have a core, and inside that core you're defining other cores, like nested inside it, right? And those are referring to each other through that outer core.
Right.
And
you maybe can get to work if you do enough explicit bunting, but it's probably not worth it.
Yeah, I mean, and it's all structural types, so you can duplicate stuff, but because the reason why it's circular, because it's not a problem if it's not circular, but the reason why it's circular is because basically a thread can send a card, which is defined in Gaul, and an agent can start a thread inline, which is going to use this type from Rand.
This doesn't bother me. I think especially because once we have user space permissions, right, there'll actually be a type that an agent can, right? Like, so the card won't be just entirely defined in terms of card, like an Arvo card.
Right.
And so that should have a nice like separation. We should just sort of sidestep this problem eventually.
Yeah. And so that's the other reason to keep this 4 letters, is because it's actually exposed into your subject unqualified. But yeah.
Yeah.
or rather, it qualifies everything under it. But yeah,
Yeah.
with stuff like like that.
It's a cross vein system right now, right? Gall and Con both kind of know about it. And so adding it as a separate thing is going to clear.
Yeah, yeah. And so then this is all the same as before. Um, this is the actual monad. It's got some interesting I forget what we call it, moist types. Um,
Oh, yes.
and then there's the bind function, which is just across the free, well, basically the free. Well, yeah,
Gently
it's its own thing,
exfoliates.
right? That's the actual magic part, where it's like, yeah, if you have, but like the combination of those two, if you were, if you're delegating to another one, then you actually like just go ahead and do it and just keep going until you're done. Um,
Yep.
anyways, there's the eval on that, which is what makes it sort of an impure monad, or impure is not the actual word, but the kind of monad that needs to be evaled. And so
Yeah.
that's all in there. It adds, I don't know, 190 lines to lull, and removes it from libstrand. But now that it's something that's like really built into Con, it doesn't matter that like it's appropriate for it to be there. It's more of a system thing.
Yeah.
Con itself, we modify to add, and that I think should have been right. I skipped over it. So in Con's task, we add. So we had lard and fired. Um, sorry, we had
Yeah.
fired and fired, and we add lard.
Well,
They're not great names,
what's
but
a bear? Oh, it's either a desk or a beak. Yeah. Okay. That makes sense.
yeah, right. And it takes a shed because that's all you really need.
Right.
And in particular, through this interface, you don't specify its thread ID or its parent ID or something. Con is taking care of all that, just like for the FARD case. Technically, you could probably use this there as well. I think that's too much interaction, and this should just be. Or no, sorry, you can't, because yeah, see that's the problem with premature abstraction like that, is you're like, both of these have a bear and a name, and so I'll abstract it. But then you add a third one and it has a bear but not a name. Oh well.
Yep.
And so like those should just be in line. But yeah. Okay. So that's what happens in lull. In Con, this was a little bit specific. Instead of making two functions, I was like, okay, well, we'll have a poke spider function and have it say whether it's doing spider start or whether it is doing spider inline. Lard looks pretty similar to
Was there another option?
FARD.
Like, you sort of phrase that as though that was one way to do it. There's a different way to.
The other way to do it would be to have a start spider and a like inline spider or something function that are exactly the same, except they like that way they can both take cages. Sorry, both take vases instead of cages. It's just a code style thing. It doesn't make it. It doesn't have any practical effect.
Yeah, it's just like which helper function you define here, right? Versus what you do in line.
Right. This requires
Okay.
you to specify this inline where you didn't need to before, but on the other hand, then you don't have like a proliferation of helper functions where you have to like be like, oh, I don't know what that one means. Poke spider, it's obvious what poke spider means. It means just poke it with this cage.
Yeah, I think this makes sense. I mean, it's like doing it that way. That it conforms to the Steve McConnell idea from Code Complete, right? A fan out, right? You want like a small number of functions that are called in many different places, not like different functions, each of which is called once.
Yeah. That's a good way to put it. I still haven't read that book.
I love that book. That's my favorite book on programming. But
Yeah,
I haven't read the art of computer.
All right, so then lard looks very similar to fard here at the top. It makes its own thread ID. It has a tick to make sure that we don't use the same thread ID if you call it twice in the same event, for example.
I mean, these two cases do kind of look like we might want sort of like one initialization function or something, but like that these should actually maybe share the same code.
Let's see.
They're really, really.
Let's see what the difference is. So the list of arguments is different. The thread
There's
ID is
con lard,
different, and this is
fired,
different.
and then the args are different, and we pass spider inline instead of spider start. Yeah.
Yeah. So it's about half of it basically. I feel like. And if there were another way of running it, another possible way of running it would be something that looks more like fired. Although fired actually just defers to fard, but
yeah, I think if we reorganize it slightly, it would look different, right? So like TID, for example, is only used in args and the call to watch spider.
Yeah.
So if you kind of group that more, then it might be sort of more obvious how you could have something that does both of these and looks reasonable.
Yeah, I mean the other way that you'd imagine this being extended is by maybe you're accepting source from the outside from Unix,
right.
and so yeah, it's not what I mean. Honestly, maybe the answer here is that it's not Dojo that unifies these. Like we were talking before about how Spider could only accept inline stuff, and it could be that Con is the one that for fard just builds the thread from forward and then slams it with the arguments and then goes to lard. That would give a natural like delegation between these.
Yeah, that might be nice. Yeah, I think the other way to try to break up, I think that long term that might be right. And then in terms of do we get these to share code right now? I mean, I think that like there's something about the actual, like if we can separate this into two phases, one is like building up the args, and then the other is actually like applying the args. So basically, like the congate turn of watch and poke with passing the note. I don't know, and the like incrementing tick.
Yeah.
Right. If you do congate with tick replaced by loss of tick, and then they're just two different ways of assembling arguments to the like actually start a thread function.
Yeah. You would presumably, yeah, like this part is the same as this, but if you abstract over that, then it's harder to abstract over this, and so
right.
You could do the whole
abstract over
cage,
that.
right? Say basically,
Yep.
You would pass in the thread ID
Yeah.
and args.
Okay.
And
args as a cage,
the bear, right? I guess. Sorry, say again.
Yeah, I guess that's
the args. Yeah, sorry, as a cage. So with the yeah, that's doable. I feel like
the minor improvement
in a whatever it is,
a little bit arguable
200 line vein or something. I feel like it's maybe a little cleaner to have the duplication of a couple of lines.
Yeah, the only thing I'd worry about at all would be that like it has the same pattern of like tis.tick with loss of tick.
Yeah.
Right, you have to remember that in all the different cases. I remember old Air had a case where like it had a bug where it wasn't doing that. Right, like that's the kind of thing where it reminds me of this like design for invariance thing, right? It's like if we can make it so every time you start a thread, like that is that start function, that start thread function like increments the tick. That just feels a little safer to me.
Yeah. I mean, if you want, we can go ahead and just like try that, see what it looks like, because let's do it. This is the end, right? We already looked at the search spider, cool. And this is libstrand. So If you're just wanting to
All right.
know
Yeah, all the rest of
what
this
what inline
looks
threads
good to
look
me.
like,
Like,
this is done, and we can transition into a little bit of live coding.
all right, let's do it.
All right. So I'm doing this on.
Actually, there's one thing I'd like to see first before
Yeah.
we do this, just to kind of close out the top level review, which
Yeah.
is what does it look like when an agent hears the response on a thread? Like if an agent defines an inline thread and then the response comes in, like what does that actually look like?
Right. So it's the same as Khan has always done it, which is that it gives. And again, it's a little bit abstracted. It gives in each of a cage and a goof, where goof is like term and tang.
Either a result or yeah, great.
Right.
And okay, and it comes in send a vow, is that right? As you just get like an on arvo call of a row. Okay. Is that a real word?
I believe that he was. This is Joshin wrote this code. I believe that he was very careful to make sure that everything was real words, even like fired and fart and stuff.
Good.
Let's see. Yeah, it apparently means like in a row or in a line.
Ah, cool. I did not know that word.
Yeah, nice one. Okay. Right. So we can look real quick at what this looks like in Kiln. So this is on the my release branch, which is notable because it actually uses this. And so the way that comes in, if we get in a row, so basically, let's see. So we've gotten a sign, we've gotten a row, p.sign a row. We're saying if
or a Faznak.
Sorry, say again.
Is it when we started the thread, like we emitted on a wire that's either Fazinit or Faznext?
Yes, that's correct. Right. So that's what we're looking at as well. This is where we're creating these threads, right? So init, produces one of these, so it's just going to be emitting, something on a wire.
Okay.
And it's lard base. We just specify ourselves, and then the shed. So lard takes a wire in a shed. We say init, and then the actual shed, which is strand rand vase.
Yeah, it looks nice.
And then we're like, okay, yeah, run this slog, run this, make sure we got a riot back. If that crashes, of course, that crashes the thread, and we get the response back as a failed thread. And then make sure that the response we got, zapcal the response we got back, return that as a vase. Does have to be a vase.
I have a question actually.
Yeah.
If an agent starts a thread, Khan is running the thread, and then the agent gets upgraded, does that kill the thread?
No.
Okay, cool.
Right.
No,
if Spider restarts, the thread gets killed. So, for example, if Zeus got reloaded or whatever, but yeah.
So does this pose any problems for agent upgrades, right? Like, is there something you have to be careful about like, if you start some sort of action? I guess it just means that like when you write a new version of the agent, it needs to correctly interpret responses to the old threads.
Yes. Or else maybe go and kill them or whatever, but yeah.
Yeah. Okay, actually, that's another question is like, is there a way that the new agent, like, is there some sort of handle that the agent can use to kill these threads? Because otherwise, basically, if you end up with a thread that was started by an old agent that ends up running forever, it could actually hold on to the old agent core in its closure forever, right? Which might include an old kernel in the general case.
Right. So there was intended to be, I'm not sure that there actually is, it be possible to kill them by just sending another request on the same wire. Let's see if we actually hold the state that would be required for that. We do not. So currently, no, you're not able to kill outstanding ones. other than you can kill everything by like there's a move to spider that you can do that directly. But yeah, that's a small, pretty self-contained task would be to upgrade Con to store that mapping of duct to thread ID, and then if you send something like a fard with null or something, or maybe a separate move, then it could kill that thread for you.
Yeah. I guess I feel like the thing to be careful about with this stuff is basically making sure that there's somebody, in the sense of like some module that's known to the system to be like responsible for cleaning up any given thread, right? Or like each thread should sort of be owned by something, ideally,
Yeah,
right? So that
which I think that the like duct wire system is basically correct for that.
okay,
Um, and
then
Con can convert that to the thread ID system.
yeah, can that be done in a way like if I emit like a whole bunch of threads inline as an agent, and then let's say I upgrade the agent and I'm going to be like, you know what, if there are any outstanding threads of that kind, just kill them all, right? And can I do that by sort of like emitting a wire that's like a prefix or something like that, or like have a bunch of
I
threads all
mean,
emitted on the
we
same
don't
wire? So
have any mechanism or like any patterns for that. Like we don't do that even for like subscriptions to Clay, for example. We're just like, yeah, you need to remember what you had if you want to cancel it. And
yeah,
the like safety around that for Clay is that you're generally requesting one more thing, and whenever that thing happens, then that subscription is done, and you won't recreate a new one,
right.
presumably, unless you actually wanted it. And we have that same
Yeah,
backstop here because threads get killed every time Spider or Zeus or something gets updated, and so it's never going to be a terrible like memory leak. But yeah,
yeah. Although there's a somewhat different issue where basically like a thread is not just a space leak, but it's also like this sort of temporary agent thing that's causing effects to happen.
yeah,
Um,
but a thread can't be doing terribly important effects because it might get killed at any time, and so presumably it's just trying to read stuff out of somewhere with retries or something like that. Um, and it might have like formal effects, but they're like formal state and yeah and effects, but they're not going to be
right.
sort of real ones because otherwise you really shouldn't be using a thread. Um, yeah, because they really can't get killed
It's
at any
interesting.
time, which is actually really annoying for Kiln using these to the point where I'm actually tempted to maybe not use them in Kiln because Kiln specifically while it's in the middle of these is updating Zeus often. Like anytime that Zeus gets updated, it's happening via this mechanism, as long as it's happening, through an OTA or something. And so the threads tend to get killed in the middle of it a lot, which is annoying. But that's a
That's
Kiln specific
fine.
problem.
It is, but yeah, it's a good example though.
Right, of how, yeah, like these threads really, really can't be doing anything terribly important. They're mostly a complicated way of getting a piece of information or a way
Yeah,
of like a relatively simple way of getting information that would normally take like they would normally be complicated, something like that.
yeah. I mean, there's something interesting where kiln, like that sort of kiln state, or like the state that kiln is in the middle of, where it's like trying to do one of these things. It sort of shouldn't have to lose that whenever it updates, right? Like ideally, it's just sort of storing that either in its own state or in like wires that will come back to it, um,
Right.
in such a way that it doesn't have to sort of stop whatever it was in the middle of and restart it. It doesn't really matter, right? Like presumably it's just like fine if you upgrade in the middle of something and so you send a couple of extra packets, right? Like over the wire to like resynchronize.
Right. As long as that doesn't get in
Um,
some kind of loop, then it's fine, really.
yeah, and it shouldn't get in a loop because you're not going to be like updating infinitely
Right.
in a hot loop, right?
Right. Yep.
Um, so it's sort of okay, but and I don't know, maybe it's not good to overgeneralize from this one because only really Kiln is sort of like doing stuff about updates where like,
Right.
where your problem if the thread gets killed because you updated, whereas everybody else, like, yeah, that happens, but that's like not what those apps are doing.
Right. Yeah. Yeah. It's not a problem for like ETH Watcher if it got killed because you got an update while it was trying to download stuff. It's fine. In 5 minutes, it'll try it again.
Yeah.
Yeah. Yeah. Okay. So that's how starting these looks like, and then the response comes back just as a sign arvo. We look at the wire, we see it's from a init, so it comes from this case. We make sure that our own state, like that we are actually in an init type of mode. Make sure that we actually got a row. I assume it's pronounced a row, not a row, but I'm not sure. And then we see, okay, did the thread succeed or not? If the thread failed, then we tell people about that, tell them why, and start the init process again. If it succeeded, then we read out the result, which is what we zap guard a pat UD here, and so we can zap gal it here. Put that in our state and go to next, which is another inline thread.
Yep. Yeah, it looks nice.
Yeah.
Nice and clean.
Cool.
All right, cool. Yeah, that answers my question.
Alrighty.
About how to handle the response. Nice. Yeah, I think this will be a lot just cleaner as an interface. I think also like long term, it's good because it sort of exposes the like. I feel like it makes it clearer that sort of agents and threads are like two sides of the same coin in some sense.
Right.
Yeah. I have some. It's a pretty vague feeling, but it's a feeling that like eventually we're gonna want something like the state of a thread will be like a vase that lives in the file system somewhere, and then there's just like the code that like updates that vase over time, right? Like each item in the sequence will be specified, right? So there's like you'll write some Hoon source file that says like how how it updates like each phase of that thread, something like that. Again, it's vague, and then that whole thing will get deleted when it's done.
Yeah, there's a whole menagerie of possibilities in that direction that are actually worth trying and seeing how they feel and seeing what's useful.
Right. And they're hard to like, for me at least, they're hard to find. It's hard for me to like concretize those and be like, okay, yeah, I'm going to build this and it's going to work, right? And so like having this, I feel like will somehow make those things seem a little bit less far away, and like maybe they're easier to experiment with.
Right. Right, because you can just be like, any way that you got a thread, you can run it, and it can be, I mean, yeah, you can do whatever you want with this. You don't have to put it into into the straitjacket of, well, write it to clay if you want to run it.
Right. Yeah, exactly.
Yeah.
Yeah, that's a good way of thinking about it.
Plus, one-liners have never been more powerful.
True. It would be nice to have something that's a little bit better than bar pass from Dojo.
Yeah.
I think you mentioned that. Where basically like the result, right?
Right.
A hep run thread thing.
Yeah, basically. I mean, you could certainly do that as just make a thread called hep run thread, put it in base or whatever, or whatever desk, and then that's. I mean,
actually, yeah.
The point of monads is that they compose, right? So they like, oh, how are you going to ingest source code from the outside and run that and run a thread based on that. How are you going to build that into con? You can also just build into a
You just
thread,
do it.
right? It's a thread that takes
Yeah. Right.
a chord. Um,
Yeah.
you can, they compose. Don't kill yourself. Like,
It either
be
takes a
careful with
chord
it.
or it takes like an actual data. If it's inline, for inline, you don't want to take a chord. You want it to take like an actual compiled expression, right? A shed.
Well, sorry, I mean, if you're pulling it in from Unix, like if or not pulling, but if Unix is saying,
Oh
I
yeah,
want to run this thread that it doesn't exist in your clay, and also maybe I don't, it's inconvenient to use Dojo because I'm a machine, not a human. Um, then
right.
being able to, I mean, obviously anything that can put pipe commands into the Dojo now is able to run a thread or is able to put a thread in there. But yeah,
Yeah, there are almost certainly a bunch of cases where what you want to do is just like, yeah, send some inline uh boon,
right,
yeah, without yeah instantiating it into a file or something, like
yeah,
from outside the system.
yeah, exactly, right,
It's like assembling a SQL query.
right.
But like it's useful to be able to do that.
You could even have a thread that takes in SQL or a noun version of
You
SQL or
could.
something and reads that out of whatever. It's a computer.
Yep.
Yeah. All right.
Yeah, it's like this thread level circularity.
Yep. Yep.